Right now, the sun is roaring. Not softly. Helioseismologists have shown that its surface is ringing with acoustic waves carrying enormous amounts of energy. If those waves could somehow reach you, they would be dramatically loud. Some estimates place them above 100 decibels. But you will never hear them. Because between you and the sun lies a region so thin that audible sound waves cannot survive the journey, the near empty space between worlds. Space is not just quiet, it is one of the most profoundly silent environments in the entire universe. But why? And is it really, truly silent? To understand why space is silent, you first need to understand what sound actually is. Sound is a longitudinal pressure wave, a disturbance that propagates through a medium, creating alternating zones of compression and rarefaction. How fast it travels depends on the stiffness of that medium relative to its density. In air at sea level, at 20 degrees Celsius, this wave travels at 343 meters per second. In freshwater, it moves even faster, about 1,480 meters per second. And in steel, nearly 6,000 meters per second. But here's the key. Sound always needs a medium. It needs particles close enough to interact and pass that disturbance along. At sea level, there are roughly 25 billion molecules in every cubic centimeter of air. That is a lot of dominoes ready to fall. Now consider space. The interstellar medium, the space between stars, contains on average just 1 atom per cubic centimeter. Compare that to the 25 billion molecules in the same volume of air at sea level. Space is not a perfect vacuum. It has sparse hydrogen, helium, and traces of dust. But the particles are so far apart that the average distance one travels before hitting another, the mean free path, is on the order of billions of kilometers. That is tens of times the distance from Earth to the Sun. A sound wave at any frequency you could hear would need a mean free path far shorter than that. The wavelength of a human voice is about 1 to 4 meters. But in interstellar space, the wave has nothing coherent to push against. It simply cannot exist. Here is where it gets fascinating. In 2003, astronomers using NASA's Chandra X-ray Observatory discovered something extraordinary in the Perseus galaxy cluster, about 250 million light-years away. The supermassive black hole at the cluster center was sending pressure waves through the surrounding hot gas heated to tens of millions of degrees. These waves were technically sound. But not sound you would ever hear. The note was a B-flat, 57 octaves below the B-flat above middle C, over a million billionth lower than anything the human ear can detect. In 2022, NASA raised the signal by 57 octaves and released it as audible sound, letting humanity finally hear the deepest note ever detected in the universe. And there's more. For the first 380,000 years after the Big Bang, the entire universe was filled with sound. The primordial plasma was dense enough to carry pressure waves that left permanent imprints on the cosmic microwave background, and on the large-scale distribution of galaxies as baryon acoustic oscillations. The universe was literally ringing, then matter and radiation decoupled, the restoring pressure vanished, and the cosmic music froze in place. While space itself is silent, other worlds are not. In 2021, NASA's Perseverance rover recorded the first-ever microphone audio on Mars. The result was eerie. Sound on Mars travels at about 240 meters per second for low frequencies, and about 250 for higher ones. This frequency-dependent speed of sound, confirmed by a Nature study in 2022, means that on Mars, over large distances, high notes arrive before low ones. A symphony would sound noticeably distorted. Mars's atmosphere is about 95% carbon dioxide at less than 1% of Earth's surface pressure, making sound both slower and far quieter. Then there is Titan, Saturn's largest moon. With a thick nitrogen atmosphere at about 1.5 times Earth's pressure, sound there travels at about 194 meters per second, directly measured by an acoustic sensor on the Huygens probe. You could theoretically speak on Titan and be heard. Your voice would sound dramatically deeper. The cold, thick atmosphere slows sound enough to shift your vocal resonances down by nearly an octave. The sun is ringing with 5-minute oscillations that scientists study through Helioseismology. The Voyager Golden Record carries 90 minutes of Earth's music, now more than 25 billion kilometers from the sun, drifting through interstellar space where no one will ever hear it play. The alien tagline got it exactly right. In space, no one can hear you scream. But the silence of space is not emptiness. It is a consequence of physics, of the vast distances between particles, of a universe that once sang with primordial sound and then fell quiet. Space is silent not because there is nothing happening out there, but because there is no one, and nothing close enough to carry the message.